Right, so let's motor through these questions, and you can obviously fast forward to any bits that you have to put through. The first three questions are fairly straightforward. The kinetic energy, calculating kinetic energy, first thing to do is write down the equation that you'll be using, which is a half mv squared, and make the appropriate substitutions. So we have a half times the mass in kilograms times 1.5 equals the second squared. You plug that into your calculator correctly, then you should have an answer that rounds to 3.4 joules. The second one involves a height, which always makes you think of gravitational potential energy. And we'll ask what is her gravitational potential energy at the top of the ladder. So if we write the equation down, mass times g times h, you can write the time signs in if you prefer. Remembering that g is, you can either say it's the acceleration due to gravity, which is meters per second squared, or we can say that g is 10 newtons per kilogram, and the two are equivalent. Either way, we just need to substitute 10 into the equation. And so the GPU then becomes 65 times 10 times 3, which gives us an answer of 1,950 joules. The third one requires you to remember that work done is equal to energy transferred. So if you can't see a way of finding the energy, that's a useful definition to remember that the work done is equal to energy transferred, and we know that the equation for work done is the force times the distance. The thing that may trick some people up here is the fact that we're given the mass, and remember the mass is not the force. The force due to gravity is the weight, which is the mass times 10, as we said before. And so to find the total work done, or total energy transferred, we need to multiply the 10 kilograms mass by the 10 newtons per kilogram IMG times 3 meters. And so this gives us a resultant energy transferred or work done of 300 joules. The next question is a little trickier in that you have to rearrange the equation. The simplest thing to do is simply put the numbers in and see where you go from there. So we want to find the velocity with a given kinetic energy. So we know that using the equation kinetic energy is a half times mass and the speed squared, or velocity squared. We need to put in the numbers that we've got. So the easiest way is to put in we've got 300 joules of kinetic energy, and that's got to be equal to a half times the mass, which is 2 kilograms, times e squared. If we want to do this algebraically, we could just say that kinetic energy, which is 300, is a half times mass times e squared. And we notice here that m is being multiplied by a half, which is the same as being divided by 2. So in order to undo that a half, we need to multiply the kinetic energy by 2. Now we're left with m multiplied b squared, and so to get rid of m from this side, we need to divide both sides by the mass. And so algebraically, we would end up with the expression of b squared as 2 times the kinetic energy times the mass. If you put the numbers in then, that's 5 times 300, which is 600, divided by the mass, which is 2, and 600 divided by 2 is 300. Notice these two will cancel out, so that is just 300, but obviously that is b squared, and so to find the velocity we need to take the square root of that, and that gives us 17.3 meters per second. 17.3 meters per second. So that's going down the purely algebraic route here. If you're not so confident about rearranging equations, remember you just put the numbers in, you can often see the solution. So here we can see that 300, in order to undo that half, let's see that you know to double the 300, so multiply that by 2. And then you can see that b squared is multiplied by 2, and so we would divide that to undo it. So quite often people can instinctively see what to do if they put the numbers in rather than using algebra first. But whichever method you choose, you get the same answer and obviously do which makes you feel most comfortable. Question number 5 involves kinetic energy. So the first part, you remember if you look at the question, it looks quite complex. There's usually a first part of the question is usually something that you can calculate fairly easily. And so if you remember always write your equation down, kinetic energy is equal to R times minus v squared. So that is R times 5 kilograms times 20 meters per second squared. And so if you evaluate that, this is 5.5 squared is equal to 10,000 joules of energy. The next bit, and this is a clue here, is using a conservation of energy find out how it's effective. And so in problems like this, remember we said that conservation of energy means that we assume that the kinetic energy is equal to the gravitational potential energy at the top of the cliff. We assume that no energy is being lost due to friction or resistance or by any other method. And so we can say that the kinetic energy at the bottom is equal to the gravitational potential energy at the top. So you've shown there that you're using conservation of energy. It doesn't matter which way around you write it, of course. And so we already know that the kinetic energy is 1,000 joules. So we know 1,000 joules is equal to the mass times G times H. And so if we substitute in the numbers, 1,000 joules is equal to 5 times G, which is 10 meters per kilogram, or 10 meters per second squared, so energy is just 10, times the height, which is the thing that we want to know. So this is the thing we want to find out. Algebraically, we've got 1,000 is equal to 10 times G times H. So to find H, you have first have a look at what's happening over here. So mass is multiplying G and H, and so we need to divide both sides by mass to get rid of that one. Then we find that we still can't get H by itself because it's still being multiplied by G, and so we divide both sides by G, which gives us the expression that we have is 1,000 over m times G. So if m times is 5 and G is 10, it is 1,000 over 50, and so the height is 20 meters. So that was looking at it from a purely algebraic point of view. If you just put the numbers in, which is the top tip and always remember people about, if you just put the numbers in, quite often you'll be able to see this relationship easier. So you notice that H is multiplied by 50, and so 1,000 joules divided by 50 equals H. So H is 1,000 divided by 50, which still results obviously in this distance of 20 meters. So the height of the cliff is 20 meters. The third one could be a little bit off-putting because it requires use of standard form, and at one point we might think that we haven't quite got all the information that we need. And at that point we need to go back to the question and see what information it's actually giving us. So we're talking about something high and energy. So let's first look at the energy. So the energy is something raised off the ground, like it falls is equal to the mass times G times height. And we're given the mass, so 7 times 10 to the 6 kilograms of water. We know that G is 10 meters per kilogram, and we know that the floors are 50 meters high. And so if you tap that into the calculator, you will find that you get 3.9, or 3.5 rather, times 10 to the 9 joules. It comes up as 3, 5 and lots of zeros, but just press the arranging button. It will send a ball for you to save count on the zeros. Now, the thing we need always to do is check at the end of the question. Well, here no, because we'll tell you what power would you produce. So if you remember, power is measured in watts, and 1 watt is 1 joule per second. And so here we've got the total amount of energy. So if you go back to the question, you can see that it says that this amount of water falls over every second. And so you have got a time, because power is the energy or work done divided by the time. So here we've got 3.5 times 10, it's 10 joules. If I do that, well, we know that all that takes place in 1 second, and so we have got joule divided by seconds. And so our power is just the same as before, 3.5 times 10 to the 9 watts. We've got the units wrong there. Okay, so I hope that helped. Any queries, please see you.